The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
Ben, it's time to start on another new project.
Yes, that's right. We're getting started on the Logic Gate board game this week. Now, we talked about this in our overview episode, but today we're actually going to start the prototyping process. We're going to think about what it needs to do, how it can be improved, how it can be made cheaper and more manufacturable, and what kind of things we'll use to make it. Like, are we gonna have different plugs? Are we gonna use a different microcontroller? Does it need to talk? Could it just beep? You know, those sort of things.
So one of the first big obstacles that we were coming up against was what kind of connectors we're gonna use.
Yeah.
So we've been talking about this for a few weeks now, and I had an idea to use these magnetic clasps that I've seen before,
Oh,
so
that'd
I
be
ordered
good.
some, and they came in.
Yeah, because if we made something with those banana plugs like in the original prototype, it would cost a fortune. So while you do that, I'm going to dig up some microcontroller dev kits that we can use to test out the system with. Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
All right, Karen, I think we should start mapping out a plan
Okay.
for the Logic Gate game.
Yeah, there's a lot of options.
We talked about it in the previous episode. I just made these printouts of what we had
Hey,
before that we can
that's
use as
handy.
reference. Do you remember we talked about getting rid of the,
We're getting rid of the flip-flop and the counter.
yep.
Those are going away. Do we want to keep the other 6, or did you want to knock it down to 4?
Well, I was going to get rid of the inverter versions. So we could do AND or XOR not.
Okay.
So that's 4 different types of gates. And the reason I got this foam core is so we can kind of mock up how big it's going to be.
Well, and weren't you also talking about, rather than having the 2 inputs for each gate with the like right next to the output?
Yeah,
having
doing it
them,
all as a line.
doing it.
Yeah, 'cause
like
this-
horizontally as opposed to vertically.
Yes, this was drawn physically, and then I'm thinking that we arrange it logically.
Yeah. Yes.
Like that.
'Cause it
Looks like
being-
little Star Trek ships.
Yeah.
Karen, talk about these things that you bought.
Yeah. So in all of my sewing exploits, I'm aware that there are magnetic clasps designed for purses. And I thought that they would possibly make a good fit for our connectors for this because
Instead of plugs.
instead of plugs, for multiple reasons. Now, I know you're concerned about diameter, but we
And
might...
cost.
And cost. And we might be able to get these in a size that are a small enough diameter, but conceptually, I want to see if they work. The appeal of them is they're steel and neodymium magnets, so they're conductive enough that, in theory, we could attach a wire to them. They already have these tabs on the back, so we could potentially connect the wires that way. And they magnetically connect, and so that it's not a rigid physical connection that
Yeah.
could easily be destroyed or damaged
That's a good
by
point.
a child. And they have the little notch in there so they nest together and are pretty, they make a solid connection, but it's easy to detach them. So that I thought was really appealing and might be
Yeah.
a good enough reason to use them over other
we-
options. Because
maybe-
like these are too flimsy. You can't use these with kids. They'll just like rip them apart.
Well, I guess we could do a test, and then maybe we could make our own thing where we have a 3D printed part that could be an injection molded part, and we put a neodymium magnet in it along with a wire.
Okay.
And then on our board, we have copper contacts or whatever it would be, and then we put a piece of steel behind it, so it wouldn't be grabbing onto the piece, it'd be grabbing through the PCB. Don't you think these are kind of big, though? I mean,
This was the smallest diameter I could quickly find and
Okay.
order on the internet. That's not to say that you can't get them smaller.
well, let's say we
And
have...
the other thing is, like, how small do they need to be? Because I mean, what's nice is that they are big. Because
Right.
like, if this is meant for kids, like, say it's for elementary school kids, you know, children of that age, like say 7, 8-year-olds, don't have the best dexterity. They don't have a lot of fine motor skills. So giving them something a little bit bigger to be able to kind of grab onto is beneficial for that age group. So rather than having something that's really small, because that's why these or like alligator clips aren't good enough for little kids, because they can't like pinch them with their little fingers. And well, for alligator clips, they don't have the finger strength for that. So the size might actually be a plus.
All right, so if we have 4 inputs on each one of these, and then we use those things.
Do you want to lay them out?
Yeah,
so you can
let's,
see the size.
For those just catching up, we can't use the banana plugs because they cost a fortune.
Are you just trying different layouts right now?
Yeah. See, if we go vertically with it, it takes up a ton of space. But if you go horizontally, it's actually a lot more compact. And if we're talking about just having 4 things total, pieces these size might not be as ridiculous as I originally thought.
Oh, you're gonna go that way?
Work with me here, Corbeil.
You need to learn to communicate.
Your name always makes me think of chicken cordon bleu. That's
So
not
what
too
if
bad.
the rows were the same as opposed to the columns being the same?
What's your thinking for that?
So that you can always go like, ooh, do I want a NOT gate, a this one, a this one, this one, as opposed to like, because if you're, well, it depends on where the inputs are.
Yeah, I see your point. So
If they're here,
Yeah.
then having columns is good. If they're here, then you want it to be rows.
I see your point. And or not.
XOR.
And if you didn't like the last line, you'd be an exorcist.
If you were, what you mean is if you were prejudiced against the last line.
You are less of a gate because you're an XOR. If you think that, then you are an exorcist. Are we still going to go from left to right?
That's what I'm trying to figure out.
I'd still like this to be smaller, although kids, have less manual dexterity.
Is it cheaper to do one large circuit board, or
Yes.
is it rather than like we did like
Yeah, it would
4
be
strips
because you
or
don't have to
something?
assemble it. Well, and we'd also want to make it surface mount. Oh, were we talking about reducing the number of outputs to 4?
Yeah, I'm thinking 4, and I'm also wondering if. So hold on, don't.
I'm just drawing.
No, I know. I'm so rather than having the design more linear, where it's left to right, and like this is where your signal is.
Right, because the problem we have with this is it's hard to see it all in your
Yeah.
vision.
So I'm wondering if you had like.
Oh, across the top?
Yeah, like you're given, and then like this is what you needed.
Actually, I do like the idea of this being horizontal because it fits more with like how logic would be written. So this would be bit 1, 2, 4, 8, 1, 2, 4, 8. So basically you have nibble, 4 bits. So I mean, you'd still have to. I mean, you'd still have your output, and then it would have this, the lights.
Well, if you, I would put the lights on top and then put the inputs below.
You mean
'cause then
the
you're-
jacks?
Or the jacks.
Why don't we? Do these represent lights? Or
Yeah, sorry, these are the lights.
Oh, okay. Well, then put your discs over here.
Yeah.
Hey, you want me to see if I can actually solder to these things? Let's disconnect and reconnect. Oh, definitely seems to work.
Bam!
Leave it together. Fully. Yeah, this isn't, this isn't the worst idea. I wonder if we could kind of create a hybrid idea, though.
Yeah, this was the beginning of an idea.
What do magnets like this cost in like mass quantities?
I mean, I feel like most things you can, well, not most things, but like these types of things you can get down to like pennies.
Well, here's a question. How many cables does this come with? Oh, that reminds me. Remember something else we were talking about? We wanted to have multiple outputs, like parallel outputs. So you could hook up 2 things at the same
Oh,
source.
God, that makes it so much more complicated.
Remember, Karen, when you're doing a
Yeah.
circuit, you're always tying wires together to make a bus. You can't do that with this.
You're thinking of it from someone that is extremely familiar with electronics. I'm thinking it from the perspective of someone that's new and doesn't understand it.
If you can only make a straight line with your circuits, that's going to limit the number of circuits you can create.
I understand.
So you need to have maybe there's other places too, just basically bus junctions, and you'd actually need 3 because you'd come in and then have 2 outs. When Felix and I are wiring up things, we're always twisting wires together. With this, all you can do is go from one point to another.
Right.
So if you want to have one connection go to 3 things, you can't do that because one connection can only go,
Right, but keep in mind that
They're
we're going to
definitely
have
not
to
pop
eventually
cans.
develop gamification of this, and so
Yes, but if we don't have a way to make some outputs parallel, it's going to limit the gamification we can create. See, we're kind of a loggerheads here. You're thinking about it from a puzzle perspective, and I'm thinking about it from a electronics perspective.
I know, but the thing is it's if the point of this is to teach, then you need to look at it from the standpoint of someone that doesn't understand this.
I see it more as a brain teaser puzzle. 'Cause honestly, if
Who's your market? Who will buy this? Is it going to be people that already understand logic gates that just want a puzzle game, or is it going to be schools and parents that want to teach their kids or themselves about logic gates?
Yeah, that's a good point. But the thing is, if we don't have things like buses, and if we don't do this correctly, then we're going to severely limit the number of puzzles we can create. We were already running into that with our first example, like the fact that you basically had no way of tying 2 wires together, severely limited your options. Like, there's a lot of circuits like flip-flops and latches where you need to tie 2 signals to 1 signal. And without these buses, we can't do that. So if everything is just wire, like direct point, it severely limits the number of things you can actually create.
Okay, you need to decide whether you're making this for someone that has never heard of a logic gate before and needs to slowly progress into understanding just how they work. Slowly progressing from the basic, okay, you literally just need to make an AND gate work, where you get 2 lights and 1 over here.
Well, it's kind of off subject, but maybe this thing does need to talk.
That's exactly what I'm saying.
Okay, all right, so here's my concern. That sounds like a programming issue. We're nowhere near that yet. We're just talking about layout.
But it's tied together to a degree, because what types of puzzles we're going to do and how the gamification is going to work is going to dictate what hardware we need.
So I found this board, but I was using it the other day, but I decided maybe it could help with this project. So we were talking about how these logic gates might work. What if it did know what was plugged in where? So that way it could keep track of what the player was doing. Because if we just have these as actual logic gates, the system will have no idea what you've done, only what the result is.
Right.
Now it's a lot of plugs, but I guess we could count. I know Karen was making a list of exactly what's there. But then I thought about this PIC32 starter kit that I had with all this I/O on it.
There's quite a bit of I/O.
So I'm thinking if we had a microcontroller that had enough I/O, we could conceivably simulate all the logic gates.
Right.
Well, we could do them with code. So you could have, these would be inputs, and then you would just call a function, and the function would just go through all of these, or maybe have a switch case statement, and say, if this and this, then this, else 0.
Yeah.
Right? How about we do this? It looks like there's jumper 10, well, part 10. So these are labeled 10 and 11, so these, even though they're numbered 1 to 60, apparently these are 2 different buses, which I guess makes sense because some of these PICs have like 80 to 100 I/O. And I have a couple different modules here. I have the PIC32 starter kit. Now you can program this on its own, or you can stick it into this. See how it's got an adapter there? This is a PIC32 MX695, or it might be a 495. And then both of these are 795. So these are like the highest end of the MX line. And I was thinking what we could do just to test this idea is we could put a bunch of female headers here and male headers here, and then just really crudely simulate like our logic gate connections, and then try doing basically a state machine loop in MPlab and see if we can get it to simulate what we want.
Sure.
Well, I think we could make this example faster by using Arduino, or more specifically, ChipKit IDE. And that might be something for developers to consider. Is your software as easy to use as Arduino? If not, then maybe make it easier. I mean, because obviously we're going to do this using MPlab when we actually go for it, but in the purpose of making a quick example, ChipKit's going to be faster. Okay, so I grabbed this chip kit, which has the same chip as the starter kit. I can make the logic gates with this. So I'll just have, I don't know, like 6 of these will be inputs, so like and, or, not, and then the right-hand side here will be the outputs. And then I'll use this LED to see what the result is. So I'm going to wire up this breadboard and then write some code so we can just see if this will work. Now, using a microcontroller will cost more, especially if it's one with a ton of I/O like this. However, an advantage to that is we could sense every wire. We could figure out exactly what's going on. We could pull the wires kind of in the background and figure out what the user's done. And maybe we could use that as a learning tool. I guess we'll have to figure that part out. And all my leads are the wrong color, which drives me mad, but I guess I have no choice. All right, so yeah, I'm gonna start writing the code. So let's see, let's use 40 to 52 here. So I'm just gonna go 40 to 54, x plus equals 2 for loop. So the ones on the left will be inputs and the ones on the right will be outputs. So we'll set that up. And then I'll just make some test code just to make sure it's working. Let's see. Digital read 42. So this part we have to be kind of careful because it would be really tempting to do this logically. Well, let me explain. Okay, let's say all you typed was if digital read 42. Now that's going to return a Boolean from the digital read function, which we can rewrite later on because it's super slow. But this is one of the reasons I switched over to this chip kit, is because we can just type in a number. Otherwise, if I was using the PIC starter kit, we'd have to use ports for everything, which would take a lot longer to test. Okay, so if digital read 42 is 1, then this result will be true, and then this code here will execute. Now if we typed this, if digital read 42 end digital read 44, now what that would do, it would be like, okay, if this is 1 and this is 1, then execute code. Well, let me explain. Okay, so typing and here is kind of like a conversational and. If this is 1 and this is 1, then execute code. And the code in this case would be digital write 41. So basically that would turn on the LED, else we turn off the LED. Now, I mean, this would actually work because if this one's 1 and this one is 1, then output. But it's not actually correct, and this would break down once we get into the ORs. So what you'd actually do is you would do a binary operator like that, an ampersand, and it's now actually going to AND those two things together, and if that still is 1, then output it. Let's change it to an OR. If digital read 40 or digital read 42, then turn on light. Okay, let's try that. Obviously, there'd be a lot more gates in our final product, but I mean, the code would execute so fast, it wouldn't be very efficient in some applications, but for our application, it probably wouldn't matter. All right, so now we have it hooked up as an OR. Okay, so I brought the connections over here and did pull down. So right now there's 0, 0. So in the OR state, if I hook either one of these up to 1 voltage, which is in my hand here, it should turn on. Cool, kick it. Let's go back to the AND. So if A and B, then we should get result. Okay, cool. Let's see. Okay, the next one, well shoot, we need pull-up resistors on this. It's almost like I should just make a more complicated breadboard because this one kind of sucks. I've wired up 8 example gates. We have AND, OR, XOR, and the rest don't do anything. Let me just give you an example. This represents our input source. Right now it's just all high. So the first one, AND, obviously you need 2 of them for it to work. The second one is an OR, so either one will work. And the next one's an XOR, which means either one, but not both will work. Oh no. Okay, so basically the top 8 bits are set to 1, which means input. The bottom 8 bits are set to 0, which means output. So then down here, these are the only 3 functions we're looking at so far. I've started to make it so it's a little bit more low level. So instead of doing a digital write, which has to go through a whole bunch of code, we can just do a latch function. So to set a bit, we do latch of port D or equals 1 bit shifted 0 to the left, so that's the LSB. Or if you want to clear it, you do lat D and equals the inverse of that. But you can go even lower level than that. You can go lat D clear, and then you can just say which bit it is. So the first bit in the LSB 0 would be a 1, the second one would be a 2, then it would be a 4. So actually, we would do lat D set, which sets that bit, and then the inverse would be lat D clear, which clears the bit. Now see how they both equal 1? So we're either setting it or we're clearing it. So you put a 1 in there, and that basically just changes one of the bits on the port. And this should work the same way. Let's just check. So I'm going to go to write our code using MPlab. If I ever get it properly installed on this computer, we'll use lower level commands like this. Although we could create our own functions, such as our own digital write functions. We just make them a lot more efficient because we know exactly what processor we're programming it for. Whereas in Arduino type code, it has to check a whole bunch of things every time you do anything, which slows it way down. All right, looks like that's still working.
The last thing Ben and I did was to create a foam core mock-up of the game board. We added PVC handles to make it easier to hold as a portable handheld game.
Well, Karen, looks like you're doing some testing already, like pretending that this thing is already built.
I'm trying to see how easily you could hold it and keep it portable and actually play the game.
I still think it's a little overly large. So that's actually something we wanted to talk to the community about. Do you have any ideas on what kind of LCD screen we could use with this device? We need something that's kind of about 2.5 to 1 ratio. We'd like just regular old school LCD, but if it was backlit color, I mean, that would be acceptable as well. Then we're also going to be looking for a microcontroller that can at least drive the screen, has enough I/O to basically give us intercommunications with all the plugs. But with the microcontroller, we can run the plugs however we want, so we can change the gates on the fly and then just do it in code.
So if you have any advice for our build or questions about what we're doing so far or what we're going to do in the future, let us know on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time. That's not good.
I was going to call you a foam core king, but then I didn't.
Foam core king.
I was going to say, have at it, foam core king.
I don't like this, Rick. We should get out of here. It's gonna be okay, Marty. It's gonna be fine. Okay, 40 and 42. You're not doing it over the shoulder because then you'd be in the shot. And you're like a toast ghost. Nobody knows that you are real. I guess if I had a kid, I'd make sure they knew binary by like age 2.
But you're not try it.
He's dead. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.